Welcome back, everybody. Before the break, we spent some time defining convergent series, divergent series, and how I can actually calculate the sum to infinity. In this portion of the lesson, we're going to be looking at some more examples with calculating the sum to infinity, and we're going to look at how the sum to infinity can be represented using sigma. Great, so before we get going with examples, I'm just going to revise some concepts. Will you look at the board with me? So the key terms that I just want to make sure everyone is happy with: series that converge. This means that when a series converges, it means that the terms approach zero and that their sum approaches a specific number. So this is the definition for a series that converges. Please remember that a series that diverges is the opposite. Cool? We then said that we can calculate the sum to infinity when my ratio is between -1 and 1 and r is not equal to 0. So when my ratio is between -1 and 1, the terms of the sequence approach 0 and their sum does approach a finite number. Because the sum approaches a finite number, that means that we can calculate the sum of the entire series. This means that we can calculate the sum of the series with an infinite amount of terms, as it is all moving towards one finite number. So the sum to an infinity allows me to calculate the value of a series with an infinite amount of terms. Great. Please just make sure that I can only use the sum to infinity when my ratio is between -1 and 1. Let's look at the next slide together. So, the formula for the sum to infinity can be written as the sum to infinity is equal to a over 1 minus r if my ratio is between -1 and 1 and r is not 0. So guys, just a reminder, this means that I will need my a as well as my r in order to calculate the sum to infinity. Let's look at the first example. So we haven't done one yet that's got a sigma involved, but just a reminder, everyone, sigma means that it is a sum of a specific amount of terms. So this sigma is indicating that I'm going to work out the series that's starting from the first term that is going to go the whole way up to term infinity. So essentially this is an infinite series that I need to calculate the value of. So we can see that this sum has the TR of 3 times 2 over 3 to the power of r minus 1. Please remember, everyone, that for sigma sums, I have to calculate the value of the first 3 terms. Calculating the value of the first 3 terms will allow me to establish the value of a as well as the value of r. So I'm going to substitute in r is equal to 1, r is equal to 2, and r is equal to 3 in order to establish the first 3 terms of the sequence. So if I have 3 times 2 over 3 to the power of 1 minus 1, I'm going to be left with 3. Then for term 2, I've got 3 times 2 over 3 to the power of 2 minus 1. And everyone, that is just going to leave me with a value of 2. Cool, guys. And then to find the value of the third term, I'm going to say 3 times 2 over 3 to the power of 3 minus 1, which is 3 times 2 over 3 to the power of 2, which is the same thing as 3 times 4 over 9, which gives me 4/3 as an answer. So we have the first three terms being 3, 2, and 4/3. We can establish by taking our ratio as term 2 over term 1. That's going to give me an answer of 2/3. So the common ratio is 2/3 because I've been multiplying by 2/3 each time. A is equal to 3 as it is my first term. So the sum to infinity is equal to 3 over 1 minus 2/3. So all I've done is I've substituted in my A as well as my R. Let's pop this all on my calculator. Then we can actually see what the sum to infinity is. So I've got 3 over 1 minus 2/3, which is equal to 9. So for this specific example, the sum to infinity is equal to 9. Great, everyone. So I hope that everyone is comfortable with the example that I've done with you. We were able to calculate the sum to infinity once we had our A and once we had our R. After the break, we'll come back and we'll look at more examples of calculating the sum to infinity. See you soon.